Let's take a look at some sample problems for section 10.5, which deals with counting problems involving not and or. Counting problems involving not and or. And we'll start with number 2. It says, how many proper subsets are there of each set? So in number 2 we have U, V, W, X, Y, Z. U, V, W, X, Y, and Z. So if we think about proper subsets are all of the subsets other than the set itself. So it would be the empty set, all of the subsets that contain 1 element, 2 elements, 3 elements, 4 elements, 5 elements, all of them except the one that contains the 6 elements we see here. And if you remember, we find the number of subsets by taking 2 to the number of elements. So since we have 1, 2, 3, 4, 5, 6, in all there will be 2 to the 6 subsets, but we have to subtract off the set itself because it says proper subsets. And 2 to the 6th gives us 64. And if we subtract 1, we'll get 63. Okay, and number 4, we have, you toss 7 fair coins, and how many ways can you obtain each result? At least 2 heads. So we're talking about the complement of 0 or 1. So with 7 coins, there are 128 possibilities. 2 possibilities for each coin. So we have 2 times 2 times 2 until we have 7 factors of 2. And multiplying those together, we get 128. So at least 2 heads, we would eliminate the case where we have no heads and the case where we have 1 head. And because there are 7 coins, the first coin can be heads, second one could be heads, third one could be heads, fourth one all the way through the 7th one. So there are 7 possibilities for having 1 head. So we end up with 120. Okay, and number 6, at least 1 of each. Okay, so again, 7 coins, we're going to have 128 possibilities, and we have only 1 possibility where it's all heads and 1 possibility where it's all tails. So that leaves 126, where we have at least 1 of each. Alright, now we're rolling 2 fair dice. We'll say red and green. And how many ways can you obtain each result? So a sum of at least 6, of at least 3. Sum of at least 3. Well, if we remember our table, we have 6 possibilities for the red die, 6 for the green die. We had 36 in all. And the only possibility of getting something less than 3 is when we get 2 1s. So there's only 1 case. So there's 35 ways to get a sum of at least 3. And you can also look at the table and count these. Different number on each die. As we mentioned in the previous problem, we have 36 possibilities in our table of 6 red, 6 green. So we have 36 possibilities. There are 6 cases where we have 2 die having the same number on them. That would be a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, or a 6 and a 6. So that's 6 possibilities. Okay, so we're using in all of these the complements. It's easier to count the ones that don't fit and subtract them from the total than it is to count the ones we're asked for. Alright, if you draw in number 12, if you draw a single card from a standard 52 card deck, in how many ways can you obtain each result? A non-face card. Okay, we have 52 cards. The face cards are Jack, Queen, and King. And so we have 3 face cards per suit times hearts, clubs, diamonds, and spades. 12 face cards in all. So that means we have 40 cards that are non-face cards. Okay, and 14, how many 2-digit counting numbers meet the requirements? Okay, so this one says, 14 says greater than 70 or a multiple of 10. Okay, so greater than, there's actually 2 ways we can do this. Greater than 70, we would start with 71 and go to 99. That's 29. Okay, and multiples of 10, we would have 9 of those altogether. If we think about 10, 20, 30, 40, all the way up through 90. But notice we counted 80 and 90 twice, so I need to get rid of those, and I end up with 36. Now, notice you could also do this, greater than 70 would be 29, and then just count the multiples of 10 that are less than or equal to 70, which would only give you 7. And that would also give you the 36. So 2 ways to get the 36 on number 14. Okay, let's go to number 16. The 10 longest Broadway runs include The Phantom of the Opera and Les Miserables. 4 of the 10 are chosen randomly. Assume order is not important. So order not important, that's telling us we're talking about combinations. So, combinations, okay, and we're talking about the 10, and we're choosing 4. So 10, okay, so I'm going to use my calculator. 10 combinations, and I want to choose 4, and my battery's dying, so let me see. Okay, 210. Okay, and part B, how many of these, those groups of 4 would include neither of the 2 productions mentioned? So if we're excluding them, we'd only have 8 to choose from. So we need 8 combinations, taken 4. So that's 70. Okay, how many of them would include at least one of the 2? Alright, so what we would take is the total 210 minus the ones that do not contain them, and that would give us the ones that contain at least one of them. So that's 140. Okay, moving on to number 20. We're selecting restaurants. Jason Ignacio wants to dine at 4 different restaurants during a summer getaway. If 3 of the 8 available restaurants serve seafood, find the number of ways that at least one of the selected restaurants will serve seafood given the following condition. The order of selection is not important. So he's looking at 8 restaurants and he's dining at 4 of them. So combinations of 8 taken 4 at a time. We just did that. That's going to be 70. And we want to find the number of ways that at least one of them will serve seafood. So we want to figure out the number of ways none of them would serve seafood. So there are 5 of them that do not serve seafood. So combinations of the 5 taken 4 at a time. This one I got to calculate. Okay, and that's 5. So these are the ways he would choose restaurants. So at least one would serve seafood. Okay. Number 24. A committee of 4 faculty members will be selected from a department of 25, which includes Professors Fontana and Spradley. In how many ways could the committee include at least one of these 2 professors? So again, we want to do the total. The ones that don't include those 2, we're using the complements rule. And we'll subtract the 2. Same pattern we've had in number 16 and 20. So in 24, from total is combinations. We're selecting 4. So 25, we want combinations. Selecting 4, there's 12,650. Okay, so we're removing the 2 professors, Fontana and Spradley. So this time we'll do 23 combinations. Oops, I gotta get to combinations. Okay, there we go. And I want to select 4, and that's 8,855. And so now I want to subtract the 2. $12,650 minus our 8,855 gives us 3,795. Committees would contain at least one of the 2 professors. Okay, 28. We're drawing a single card from a standard deck. Use the additive principle of face card or a black card in 28. Face or black. Okay, so we said we had 12 face cards. We have 26 black cards, so 12 plus 26. And how many black face cards are there? Well, the ones of clubs and the ones of clubs and spades. For a moment I went kind of blank there. Okay, so it looks like 42. Is that right? 32. It's going to be 20. It's going to be 32. Okay, so we have 32 possibilities in that case. All right, 34. Rolling right along.